Okay, let's continue with the notes. Now that you've explored central angles and inscribed angles in GeoGebra, there's two theorems we want to mention. The first says the measure of an arc equals the measure of the central angle. So in this example, angle AOB is a central angle, and the measure of arc AB, let me highlight that for you. The measure of arc AB, there to there, is going to equal the measure of the central angle AOB. Okay. All right, the second theorem, which was a little more interesting, says the measure of an arc is twice the measure of an inscribed angle. And we investigated that, and we had a setup similar to this in GeoGebra. And it turns out that if we measure the arc from A to B, that winds up being twice the angle that we get for the inscribed angle, angle ACB, or BCA. So for example, if the measure of the arc, the red, is 80 degrees, the measure of the inscribed angle will be half of that, 40 degrees. If I give you the inscribed angle, let's say it's 70 degrees, then you know the measure of the arc will be twice that, so it'll be 140 degrees. So there's two ways to think of this theorem. You can either say that the arc is twice the inscribed angle, or you can say it backwards and you can say that the angle is half of the arc. All right, let's take a look at an example. You might want to hit pause and then copy this down and try and answer it, and then press play again to see if you got the right answer. All right, so in this picture, we have a central angle, angle PQR, and we have an inscribed angle, angle PSR. Notice both of these angles go to the same 2 points, the point R and the point P. So because the central angle is 110, we know the measure of this arc from P, the minor arc from P to R, or R to P, will also be 110 degrees. Because the measure of the arc equals the measure of the central angle. Now to find the measure of the inscribed angle here at S, we know the inscribed angle is only half of the arc, which means it's also half of the central angle. So the measure of angle S is going to be 110 divided by 2. So that gives us 55 degrees. The measure of arc PR I've already written. That's 110 degrees. It equals the measure of the central angle. And then finally, let's go to purple. Let's find the measure of arc, major arc PSR. So that means we're going from P to R, but we're going the long way. We're going to go through S. So that's all the way around here until we get to R. So notice the red arc, the red minor arc from P to R, and the purple major arc from P to R together make up the entire circle. And we know the measure of the entire circle is 360 degrees. So to find the measure of the major arc, P through S to R, we can simply subtract 110 from 360 degrees, and that should give us the remaining arc, which is the one we're looking for. So the measure of major arc PSR is 250 degrees. All right, there's one more theorem that's of interest to us at this point, and that says that if you have a quadrilateral inscribed means drawn inside of. If a quadrilateral is inscribed in a circle, like the one in the picture, then the opposite angles are supplementary. So that means that angle A and angle C, because they're opposite angles, will add up to 180 degrees. So the measure of angle A plus the measure of angle C equals 180 degrees because they're opposite angles. And it's inscribed, which means all 4 points are on the circle. Likewise, angle B and angle D are opposite each other. So that tells us that if we add angle B and angle D together, they should also equal 180. Now notice, it doesn't mean that all these angles are equal or any of them are equal. They could all be different. But we know all 4 of them should add up to 360. But if I tell you, for example, that angle A is 70 degrees, then you know angle C, which is opposite, must be 110, because 70 plus 110 is 180. If I told you angle D was 105 degrees, then you know angle B would have to be 75 degrees, because then they would add up to 180. So all I have to do is give you one, and you can tell me the one opposite it. Now the reason this works is if you think about it, look at angle A. That's an inscribed angle. Angle A is going to be half whatever the measure of the arc from D all the way around through C to B is. Angle A will be half of that amount. And then angle C is going to wind up being half of the arc from D through A around to B. Notice those 2 arcs together make the whole circle, which we know is 360 degrees. So if A is half of the purple and C is half of the blue, then together they must add up to be half of the purple and the blue together, and half of 360 is 180. And so that's why we know that opposite angles add up to 180. Okay, so now you're ready to work on the worksheet, and hopefully you have a better understanding of circles.